problem number 2, finding the probability of independent events. So here, the definition of an independent event and taking the probability of that is if I have the probability of two events, say A and B, the probability of A and B both happening, if and only if they're independent, then I just multiply their two probabilities. Okay, so as I find the probability of these events in problem number 2, I have a desk drawer containing 5, 6, 3 pins, 24 paper clips, 16 paper clips. If you select a pin and a paper clip from the drawer without looking, what is the probability that you select a blue pin and a white paper clip? So here probability is labeled like this, probability like that. Okay, and so are these independent or dependent events? So if I'm reaching in and just going after the pins, right, that doesn't affect when I just go after the paper clips. So these are independent events. So then I can find their probabilities just by taking each probability of each event and multiplying. So the probability of, here's the question, what's the probability of a blue pin? So blue pin, oops, probability of blue pin, and that word and, if they're independent, means I'm going to be multiplying their two probabilities. And white paper clip. White paper clip. Okay, so that would be the probability of the blue pin times the probability of the white paper clip. Okay, so probability of blue pin would be how many pins are blue out of the total number of pins, right? So I'll bring this down here. So there's 5, 6, so that's 11 plus 3 is 14. So out of 14 total. And how many are what I want? Blue. That would be 6. So 6 out of 14. And then for the paper clips, okay, the total amount of paper clips, 24 plus 16, so that's 40. And then how many are white? 16. So that's my numerator. Then I can just multiply these. And I can just multiply straight across, top times top, bottom times bottom. Or I could go ahead and reduce this, right? So this would be, what, divided by 8 would be 2, divided by 8 would be 5, divided by 2 would be 3, divided by 2 would be 7. So now I can multiply across 6 over 35. And so I could use it, leave it as a fraction. So the probability of blue pen and white paper clip would equal 6 out of 35. Or I could go ahead and do a decimal out of that. Or I can leave it as a percentage, right? So we talked about probability from last chapter. I can leave it as a fraction. I can leave it as a decimal, so approximately 0.17, or I can turn it into percentage, 17%, right? So any of those three would work. It's the probability of blue pen and a white paper clip. Okay, go ahead and try this one. You have a standard number cube, so if you have a number cube 1, the other side is 2, 3, 4, 5, and 6, and then you have this spinner. So are these independent events? If I do roll dice, does that affect my spinner at all? Okay, and then you want to find the probability of rolling number cube less than 3, and a spinner that lands on a vowel out of these numbers here. Okay, so go ahead and do that.